turbo pressure looks good.
Following up. Roger, roll, Atlantic. Water tower, fly! Flight outside of speed off. Speed off.
Yikes. You bet. Okay. We don't need any more of these.
All right. Good morning, folks. Let me know if you can hear me and see me. I'm going to echo myself. It sounds like you should be able to hear me because you just heard right again. We are here for another NASA spaceflight live stream this morning. Give me a 5x5 in chat. I've got chat all over the place here, but we have a really cool stream. You don't get to see this very often at all. We are standing by for the rollout of the Mars Perseverance rover on top of a United Launch Alliance Atlas V. Chris Gebhardt, assistant managing editor for NASA Spaceflight, is down at the Cape with the remote broadcast unit that we've got stationed down there at Cape Canaveral with Chris, and we are going to get a live view of the rocket actually leaving the HIF and rolling all the way to the launch pad. Remember, when they build an Atlas V, they put it together. They integrate it in the HIF. The VIF, it's the VIF, DOS. The VIF, the vertical integration facility, because it's like this, it's not like this. And they stack the different pieces of the rocket up on it. They actually integrate Perseverance in its capsule and up on the top of it with a payload fairing. And they have a crane that goes up and puts it over there. And then the entire rocket rolls in its vertical orientation all the way out to the launch pad. So Chris G is standing by. Let's go and check in with Chris G and see how his video is doing. That's going to be right here. Chris, talk to me. How are you doing?
Well, I'm doing just fine. How about you, Das?
Oh, busy here today. That's for sure. What do we see back there in the background?
Yeah, it's not like we've got a busy few days coming with this being the first of our major events. But yes, what you are looking at is Slick 41, space launch. I'm not sure how much the local road noise is picked up here, but a ULA van just went by.
You're good, Chris.
All right. But yes, we are here at Pad 41 is what you are looking at, Space Launch Complex 41 at the Cape Canaveral Air Force Station. On the left-hand side of your screen, you see the vertical integration facility where the Atlas V DOS, as you were saying, is stacked and integrated. And then on the right-hand side of your screen, you see the 4 Lightning towers and you see the crew launch tower for Starliner. And that is the actual pad that Atlas will be rolling out to here momentarily. Rollout was supposed to start about 18 minutes ago. They do appear to be slightly behind schedule, but no real reason for concern or anything in that regard. But we are actually here on one of the camera mounts, just like southeast of the actual launch pad. So we are actually at one of those camera tracking stations for the rollout. And some of our other colleagues are actually at the LC-39A observation gantry awaiting rollout. And I mentioned this because I want to make very clear that even though there's restrictions, even though the number of people and the number of reporters and media outlets that could be here at the Kennedy Space Center and Cape Canaveral Air Force Station for this launch, for safety guidelines with the COVID-19 pandemic, NASA Public Affairs has really tried to make sure that everyone gets to see these things, even if they have to split us up into different locations or whatever. So some of our colleagues are out at a different location and I am here. But it is a good way to shout out to NASA that they have done everything that they possibly can within the guidelines to make us safe, but to also provide access not just for rollout, but for pre-launch activities as well. And then, of course, the launch scheduled for Thursday morning. So what we are waiting for here, it should take about an hour for the Atlas V to roll from its integration facility out to its launch pad. We should be able to see the side-mounted solid rocket boosters. We'll be able to see the Atlas. We'll be able to see the 5-meter payload fairing. What we won't be able to see as Atlas rolls out to the pad is the Centaur upper stage and the Perseverance rover itself, both of which are enclosed inside of the 5-meter payload fairing of the Atlas V rocket. And also of note, because this one gets overlooked a little bit, but it's a really cool part of this mission, it is the Perseverance rover, but Perseverance is also traveling with Ingenuity, a little quad helicopter drone that they are going to use to fly around and assess the Martian terrain and find cool science targets for Perseverance, and also use it as a technology demonstrator for the drone science laboratory mission called Dragonfly, which is going to Titan later this decade. And that is on the Perseverance rover as well, for liftoff tomorrow, or for liftoff on Thursday. So that is where I am. It's actually a gorgeous day here, Das, at the Space Center. It's overcast. It's not overly muggy. It's not overly hot and humid yet. So I'm happy that rollout is this early right now, from how things normally go.
It looks fantastic. I mean, a lot of times it's the sun beating down and that sort of stuff, and the overcast is good here because you don't have to be standing out in the direct sun. Now on launch day, we want it to be a little bit different, but since we're not launching today, it looks fantastic out there.
Indeed. And to that point, there's actually the weather forecast is 80% chance of acceptable weather conditions throughout the 2-hour window. On Thursday, those odds get better the following day, actually on the backup day, and everything. And hang on, guys, 1 second for me. Real quick, Dust, if you want to take over.
Yeah, no worries. It looks like we're looking at the weather constraints for the launch day, and that countdown in the upper left-hand corner, you see where it says T minus 45, 27, 28, 27, 26, 25. That is the correct countdown for the primary launch window, if I'm not mistaken. Today is Tuesday, and that launch is pretty early in the morning on Thursday. So we are just hanging out. I think Chris is probably moseying over to see what's going on, see what the schedule here is. We were scheduled for Chris to be over there from about 10 Eastern till about 11 Eastern. If it takes about an hour to roll, I imagine he is maybe seeing if we will be able to stay here during the entire roll, or is he going to have to leave at the end of the window we were allowed to be there? Because this is not something that you get to see very often. This is not it's something that really gets shared a lot of the times. They roll it out whenever they need to roll it out. It's in the middle of the night. There's no media there, et cetera, et cetera. But this is a big launch. This is United Launch Alliance sending another mission to Mars. They've sent, I can't even tell you the count of how many missions United Launch Alliance has sent to Mars, but they, I guess, thought it was a big enough deal that they invited a couple people over there. Again, maintaining the social distancing, maintaining all the COVID precautions. They don't have 500 media members all packed into a bus or anything like that. It's a limited number of people that are able to come and do that. And you know, luckily, we're very fortunate that they let NASASpaceflight bring not only just a camera set, but a live stream set up over here so we can share this roll with you this morning. So I'm sure we'll get Chris back here in a second. Again, we are standing by for the roll. I'm here, Chris.
Yes. Hey, no, sorry. People were driving up on the camera mound, and public affairs were trying to talk to them and tell them what was going on. And I didn't want that being broadcast.
Gotcha. Yeah. we did hear
and
that
course,
there's
all the people who arrived to work aren't wearing masks and aren't following rules. So, yes.
Geez. But I was just mentioning what we see on the screen there, Chris. On the left-hand side, the United Launch Alliance Vertical Integration Facility. You can see it's got the flag on it. It's got the ULA logo. And then over on the right-hand side, that is the launch pad. The tower, sort of the weird Tetris piece-shaped thing there, is actually the crew access arm.
Yes, indeed. Yeah, that's the crew access tower for Starliner, which we have seen them use in December of last year during the first OFT orbital flight test mission.
Yep.
We saw that arm being used for the first time, and we saw the teams from Boeing, who will be the closeout crew. I believe they call them the blue team for Starliner, go out to the pad and pretend that there were crew so that they could actually use the uncrewed test flight to practice all those procedures of putting the crew in and how you close out the vehicle for flight when you have people. And that's something that they will repeat on OFT2 as well. I do just kind of want to draw your attention to the very, very right side of the screen.
That guy walking?
Just past the Starliner tower.
Yep.
Not the guy. No.
Sorry.
Greg. But just above Greg.
He's like, I'm in the shot.
No, because from this vantage point, you can actually see 39A. You can see the two commercial crew launch pads together.
Oh, yeah.
from this angle. And the reason I want to point that out is because just about 30 minutes ago, NASA announced the Crew 2 mission and the people who will be flying on it in March. NASA confirms that Crew 2, like Crew 1, will be a SpaceX mission using the Dragon Endeavour, which is currently docked to the International Space Station, and using the Falcon 9 first stage that will launch the Crew 1 mission here at the end of September. And the 4 people who will be flying on Crew 2 are Shane Kimbrough and Megan MacArthur from NASA. Shane will be the commander and Megan will be the pilot of the mission. And they will be joined by European Space Agency astronaut Thomas Pesquet of France and Koichi Wakata of the Japan Aerospace Exploration Agency. So they will be the second long-duration crew to launch on commercial crew missions. And I thought that was a perfect way to get all of that in there by showing you the 2 commercial crew launch pads all in one shot.
Yeah, that's fantastic. That's a cool vantage point. I mean, I know we're here to see the United Launch Alliance pad, but it's really hard to point the camera in that direction without also showing 39A. So
well, exactly. And I thought it was kind of relevant because you're looking at commercial crew pads, you're looking at all of that. And we have been talking a lot on our streams, right, about exactly what vehicle would be ready to fly in March, right, for crew in March of 2021. And we got that answer today. So I thought that was very important to push out there as well.
Absolutely.
Because this is the commercial crew program working exactly as it should right now, with one provider doing the work while the other provider fixes issues and stuff that they've had, which was exactly the redundancy we wanted for situations like this. So
yeah. So I'm going to grab a couple things. I've got some super chats here. Rough Rider Show,
100%.
Daily super chat to all the NSF team. Good luck, ULA. And Starship later today. Rough Riders, every time we go live, you toss a super chat in there. So we really do appreciate the support. Y'all were able to do cool things like this, pay for modems and bandwidth and cameras and travel around to get to these places because of your support. So Rough Riders, thank you so much for the super chat there. And then Chris, I've also got some questions queued up if you're ready for me to start rolling questions to you.
I am indeed. I'm also going to zoom in because
we
have a booster making an appearance. Hang on.
Oh, it is. You can see the SRB at the bottom.
You can totally see the SRB right there. Photobombing us as it starts to roll out of the VIF.
Oh.
So here is Atlas V. Let me get it out.
There you go.
There is Atlas V beginning to make its appearance as it heads toward the launch pad. And I know we're going to have some super chats here and some questions. But just to start the overall process, what you are looking at is the Atlas V in its 541 configuration with a 5-meter payload fairing, 4 solid rocket motors from Aerojet Rocketdyne. These are the AJ-60As on board, and a single-engine Centaur upper stage is the configuration for today. And Das, if you want to start, keep going with the super chats and start with some questions here, I'll go ahead and get us a quick pano of the rocket here as it rolls out with all of its payload fairing art that we've got.
Absolutely. So the first one here is from Vipster. And Vipster's question is, NASA spaceflight, will there be a static fire for this rocket? And if so, will we cover it? So Atlas V, it's got SRBs on the bottom. Static fire, yes or no, Chris?
No, they do not do static fires on the Atlas V at all. What they do for some missions like, but it's a good question, because what they do for some missions like Perseverance, like all of the interplanetary missions that ULA and the Atlas V launch, is they do what's called a wet dress rehearsal. So several weeks ago, they hauled Atlas V out with everything except the Perseverance and Ingenuity payloads on board. They hooked it up to the launch pad. They fueled it with oxygen and liquid oxygen, kerosene, liquid hydrogen in the Atlas booster and the Centaur. And they took it down through an entire countdown and then simulated engine start and liftoff. But they didn't actually light the RD-180 on the base of the rocket. And they do these wet dress rehearsals for the same reason that SpaceX does static fires. And a wet dress is basically everything except lighting the engine. It's a full-up countdown on launch day. The only thing you don't do is light the engine.
Right.
So they serve very similar purposes. And one thing in particular that the Atlas wet dress rehearsals are designed to find are issues with the rocket or the ground systems that, if you found them on launch day, could delay your launch several days, which you don't want in short interplanetary launch windows.
Yep.
And they actually found an issue with a sensor on the Centaur, and they were able to fix that. And now we still have 15 days left in our window, instead of discovering it on Thursday and having a panic moment of, we have 15 days to roll back, solve the issue, roll back out. Now we don't have that stress. So no static fire, but wet dress rehearsal instead.
Excellent. So that is a fantastic question. The other brief mention there is the SRBs, because they are solid rocket motors, we can't really static fire them. The fuel for them is static fired when they're made, right? But once the casings are set and the fuel is poured into it, that's a sort of, once you light it, that thing is carrying something to Mars. So we don't typically have the dress rehearsals. I just listened to you say dress rehearsal so many times. I just repeated dress rehearsal. We typically don't static fire those.
This is like what Thomas did to me on the last NSF Live, where he mentioned Curiosity's name, and then I could not remember Perseverance's for the entire rest of the stream. And I was like, what are you doing to me?
It definitely happens, that's for sure. Let's see here. I've got another question. Oh, actually, a super chat. Somebody was watching last night, it looks like. Ron Smith with the $5 saying, coffee for Dawson the gang after last night. Ron Smith, thank you so much for the support and keeping us caffeinated here with all these wacky live streams that we've got going on.
Yes.
Here's a
but
good
also,
one.
These are the
Go
types
ahead.
of things like, well, I just wanted to say too, like the channel memberships, the support, the super chats and everything. Like, they don't just go to support like me and you, Das, right now for this stream, right? Like, it's what helps us maintain two completely different sets of equipment, two entirely different production lines, basically, out at Boca and then here in Florida and in Cape Canaveral. Because, you know, Mary and I aren't FedExing or flying things back and forth to each other, you know, that quickly. We actually have two complete setups that we use, which allows us to cover everything from around the country, really. So it is that support that means the most to us, because it's what allows us to keep doing this with our two separate production gear.
Yep. Absolutely. So it's true. There's no way that we could ship these broadcast units around. There's too much going on, which is such a good problem to have, right?
It really is. I mean, so much so that, right, like on our back end, like we're going to have a plan of like, all right, if they do something with Starship on Perseverance's launch day, who's working what? Like whose team this, whose team that? Like, yeah. It's a good problem to have.
We're actually set up for that today. If something starts happening at Starship, we have two complete production workflows. We can go live from Boca Chica at the same time we go live from Cape Canaveral. So again, we're able to do that because of y'all. 66 Miss Pixie, another $20 there. How does this is actually a super chat question with 20 Australian dollars. How does the rover eject from the main tandem once in the vicinity of Mars? So what sort of happens as it approaches Mars, Chris?
Yes. So the answer to that kind of goes back to what will happen Thursday, after the Trans-Mars injection burn is done by the Centaur. And after that, the Perseverance rover, in its aeroshell and cruise stage, completely encapsulated in that, will detach from the top of the Centaur, and that's what will do the cruise to Mars. It has little solar panels on the cruise stage to keep it powered and keep it healthy, and data lines and antennas and everything to talk back to Earth. But then as it approaches Mars, the entry, descent, and landing stage, the aeroshell, will separate from that cruise stage. And then it's the aeroshell and entry part of the vehicle, right, in its aeroshell, that will slam heat shield first into the Martian atmosphere. It will use friction with Mars's atmosphere for the first couple of minutes of the 7-minute entry, descent, and landing sequence. It only takes 7 minutes from the time Perseverance slams into the top of Mars's atmosphere to the point where it touches down on the planet's surface. So it's a very, very quick and rapid sequence of events. The first couple of minutes are aerobraking, with that heat shield, with that aeroshell, using the friction of Mars's atmosphere to slow down, just like we use the friction of Earth's atmosphere to slow down during atmospheric reentry at the end of missions here. But then the fun begins, because after aerobraking in the atmosphere, Then a large hypersonic parachute deploys to slow us down even further. Then the heat shield pops off the bottom of it and just falls away. And then the entire rover just drops out of the back of the aeroshell, just free falls out the back of it. And it has a huge retro rocket pack that is strapped onto the back of the rover. And the retro rocket pack will then fire to bring the whole landing system basically about a couple of meters off the ground of Mars, where it will then hover with the retro rockets firing, and then a little winch will sky crane winch the rover down onto the surface of Mars, and then disconnect, and then the retro pack flies away and impacts the ground about a kilometer away.
Right.
But that is how Perseverance gets to the ground on Mars. It uses the same sequence that its cousin Curiosity used in 2012. August of that year when it arrived on Mars. So only the second time this entire sequence, as described, will take place.
Gotcha.
But it's a gutsy landing. Let's call it that. You've got atmosphere, a hypersonic parachute, retro rockets, and then a sky crane that winches you down to the surface of the planet. It's insane.
And after we get down safely, they're going to launch a helicopter drone. So this is like, this mission has all sorts of cool things going on for it. Go ahead.
Yeah. No, exactly that. And then after it lands, you nailed it. Like a few weeks or a month or two after it lands, a helicopter drone appear from the top of it and go off and do some scouting for it. Like,
almost like a Rube Goldberg exploration of Mars. Like
it really is. But NASA and landing on Mars is incredibly difficult. NASA makes it look incredibly easy, even though it's very, very hard. We talk a lot about how the overall success rate globally of getting missions successfully to Mars is only 48%. There are more missions that have failed than have succeeded.
Right.
When we talk about landing something on the surface of Mars, NASA has a near perfect record. Not perfect, but a near perfect record. And when you account for rovers, NASA has a perfect record of getting rovers to the surface of the planet, of another planet. It's incredible. But very difficult, very hard, and just because it's NASA doesn't mean we shouldn't understand the complexities and everything that can go wrong with these missions. Yeah.
Chris, there's a lot of super chats piling up today, which is surprising. Usually it's all
awesome.
Starship super chats, but we're getting super chats while we're watching a rollout here. So I gotta hit these really quickly. Starman Steve, thanks for all your great work. Thank you so much for the support, Starman Steve. I'm not actually sure if that one came through twice because I've got it in my queue twice, but Starman Steve, if you intentionally did that twice, I appreciate it twice. And then I've got a bunch of questions piling up as well. One here is a super chat question, and then we need to speed run a couple questions from chat. Sandy AP asked, will the new Vulcan rocket use the same assembly building and mobile launch tower as the Atlas V? And will Atlas V completely retire once Vulcan gets going?
The answer to both of those are both excellent questions. And the answer to both is kind of yes and no. Which is always fun because that's on the surface, it's such an aggravating answer. But I think the reasons behind it both being yes and no are really fascinating. So Vulcan will use the same vertical integration facility that Atlas just rolled out of. It will use the same launch pad and the same overall attach points to its launch pad that Atlas V uses. It will not use the same mobile launcher that you see Atlas stacked on now. Vulcan has its own that's actually being built and assembled and outfitted right now.
Right.
Well, it's being outfitted right now in a building that I cannot turn the camera to show you. Unfortunately, per rules of being here, you're only allowed to really film where they tell you you're allowed to film and then what's within range behind it, which is why I could show you 39A earlier. But it's being built down there, so that's what Vulcan will use. Now, the idea is that Vulcan will replace the Delta IV Heavy line and the Atlas V line. However, the exact last date of the Atlas is not known yet. And Atlas V still has to fly Starliner and crew up to the station on it. Atlas V still has a lot of missions contracted to it. So exactly when the last Atlas will be before the transition to Vulcan happens is unknown. But they will pad share until the Atlas line is phased out. That is the ultimate plan. Yes.
Gotcha. You mind if I just hit you with some more questions here?
Yeah, go for it. Hey, we've got nothing except the rollout. So
I just did a tweet where I said join us for a live interactive Q&A with Christy NSF, so I feel like I need to ask some interactive questions here.
I think that's a good idea. Yes, we don't want to do false advertising here.
So here is a question from Mr. Man, and it says, if the rocket was beside a skyscraper, it almost is beside a skyscraper next to the VIF there, but how many stories do you reckon it'll get to? How many stories tall, or how tall is the Atlas V on its mobile launcher there?
Oh, that's an excellent question, which I would totally look up on my phone, except looking it up on my phone will disconnect the audio.
With the payload on board,
off the top of my head, I do not know how many stories the Atlas V is, but that's something that we can easily figure out.
Yeah, I got it, Chris. I got it.
Yeah.
With the payload on board, the launch vehicle is 188 feet or 57.3 meters. Now, I don't know if that includes the transporter or not, but this says the rocket with the payload on board, the launch vehicle, so I don't think that would include the transporter, is 188 feet or 57 meters. So I think it's going to be 200 feet or 60 meters tall. And how many stories is that? What's the conventional wisdom? Bless you as well.
Oh, thank you.
I got you.
Sneezing with a mask, that's fun.
Oh, geez. It's about 14 feet in a story. And so 188, I'm just going to say it's 200 feet, right? And that would make it 200 divided by 14, about 14 stories tall in terms of normal height of a story of a building. So there you go. That's a good question. And we did a little quick math and Googling.
Yay, math. See, science, it works.
Thank you for the question there, Mr. Man. Here is another one from EMS Rocketry. And they said, are Ingenuity's propellers made of carbon fiber?
Ooh, great question. I have not seen a document about what exactly Ingenuity, what compounds.
I got your question. Yes, I looked it up just now. So I just put an image on screen from NASA's website that explains it. So, yes.
Michael, is that you?
Yeah.
Oh, hey. We can barely hear you. Yeah, we can barely hear you here.
Oh, I was just telling him the answer is yes.
The answer is yes. Okay.
Okay, yes.
The answer is yes. Martian or Ingenuity's propellers are made of carbon fiber. There you go. Oh, here's a good one, Chris. I'll toss this one to you. This one's from Klaus. I thought the ULA building normally moves away and not the rocket. ULA has a couple different buildings out there, don't they, Chris?
Yes, they do. So for the Delta IV Heavy family, yes, the mobile server structure retracts away from the rocket. The rocket is actually stacked on its launch pad and its launch stand, which is static. That happens out at Vandenberg Air Force Base as well. And for the Atlas at Vandenberg, the same thing. The building moves away from it at Vandenberg. But here at Cape Canaveral, it's the opposite. It's integrated in the vertical integration facility, and then it is taken by rail the 1,200 feet out to the launch pad.
Right, for the Atlas V, but over
for the Atlas V, yes.
37.
Delta IV,
yep.
Yeah.
And we're working a little bit of an audio issue on the back end here. We're trying to see what the deal is, but yeah, I was saying the Atlas V definitely rolls out. You can see it's actually on a specialized, I believe it's a diesel electric sort of train. There's two sets of train tracks there, and they have diesel electric. I believe they're diesel electric. Chris, am I correct on that? Do you know?
I believe they are, yes.
Yeah, and so it's basically a very specialized train with two sets of train tracks, so 4 tracks total that roll the rocket over. And then what you may be thinking about there, Klaus, is over at the Delta Heavy pad for the Delta IV, or just the Delta pad, I guess. There they actually have the building that is on train tracks and it rolls away. But for the Atlas V that we're looking at right now, that is on a very specialized carrier. You can see it there. You see the two trains that are sort of next to each other that push that from the VIF over to the launch site. That's an old picture of the launch site. Look, there's no crew access tower there. Chris, I know you can't see it on remote like that, but That is an older variant, it looks like.
That's from the Mars Curiosity rollout.
That's from Curiosity. Thank you, Michael.
In
All right.
2011, yeah.
Yeah. Gosh.
And that was before the commercial crew program really existed.
And that actually goes right into the next question here. NASA Spaceflight, can you put up a pic of the crawler moving the Atlas V for those who haven't seen one?
There you go.
That's what you see on the left-hand side there. You can see 2 diesel electric locomotives there. I should just say trains, basically, but then there's a specialized structure that's connected to both, and it pushes it right over to the launch pad after it's been integrated in the VIF.
Indeed.
All right. So the questions are coming in faster than we can answer them. Patrick O'Sullivan asked, is the second stage inside the fairing?
Yes, it is. Great question. So, yes, for the 5-meter payload fairing configuration of the Atlas, the Centaur is actually completely enclosed in the payload fairing. Yes.
We've got a graphic for that on the screen there. We've seen Tori Bruno tweet about some answers to why that is the case in the past. On the Atlas 5 series, which has the big 5-meter fairing up at the top, the Centaur can't typically take all of the loading that happens with a payload that's the size that would need the 5-meter fairing on this rocket. And so here, the payload fairing actually also helps move some of the load down to that boat tail and down to the core booster stage instead of putting it on the Centaur. The Centaur is super efficient. It's super lightweight. It has that really efficient engine on it, the RL10 C1 engine, and they don't want a lot of extra weight. So you don't put big steel girders on the side of Centaur to help bastion up the payload, I guess. You want it to be super lightweight, super efficient, so it puts all of its energy into accelerating not dead mass, but the actual payload to Mars or wherever you're sending it. So that fairing there is something that you can actually discard. Once you get out of the aerodynamic regime that has all the forces there that you need to transfer down to the booster, that payload fairing actually comes off, and the second stage comes out, and it keeps pushing that Mars 2020 spacecraft. You can see it there at the top of the diagram on its way to Mars. So that's a really good question, Patrick. Thank you for that one. Let's grab another one. Here's one. Martin Smith. This is a good question, Chris, about the launch pad here. Why is the rocket put on the pad so early when it's open to the weather?
That is a good question. This isn't actually early. We're less than 2 days away from liftoff.
Yep.
Right now, actually, 48 hours from right now, the launch window will already have been closed for an hour, to put it into perspective. So this is actually very quick and very soon before rollout. Remember some other rockets, the Delta IV is actually assembled on its launch pad and doesn't roll out, so it's on the pad for a lot longer. The Falcon 9s depend on the mission. Sometimes they don't bother rolling back into the horizontal integration facility after they static fire a few days before launch. Sometimes they stay out at the pad. The shuttle stayed out for 30 days. The SLS will be about a week on the launch pad under normal operations. So this is actually fairly quick for Atlas in terms of the overall rockets around the world and when they roll out. This is fairly typical of a rollout. Now, rain and stuff like that, not an issue. The only thing we would really be concerned about in Florida is lightning.
Yep.
And those 4 towers that you see there at the pad protect the vehicle from lightning. So let's go with later today when our regular afternoon thunderstorms roll overhead. If there is a cloud to ground lightning strike that is triggered by the natural environment here, the strike, if it was coming down toward pad 41, would hit one of the 4 lightning towers.
Right.
And then the wires that exist around them that create like a big Faraday cage around the pad would channel all of that electrical energy harmlessly down to the ground and protect the rocket and the multi-million-dollar payload.
Yep.
On it. So that's how we protect vehicles from the elements here in Florida. Now,
Cool.
There are things that you just have to toss your hands up in the air and go, if it's going to happen, if it's going to happen. And the big one of that is hail. There's nothing that we can do to prevent hail damage once rockets are rolled out to the launch pad. And that's something, it happens so infrequently that you can't live your life afraid that an afternoon thunderstorm is going to produce hail. You just got to roll out and take the shot, and if it happens, deal with it.
Yep.
But like I said, it happens so infrequently. The last time there was a hailstorm that came over here, that when there was a rocket on the pad that actually damaged the rocket, was STS-117 in Space Shuttle Atlantis in 2007. So it's been a very long time since we've had something like that happen.
Of course you would know that.
Well, yes. Yes, indeed.
I appreciate you. I'm like, he's going to tell me the last time that it happened, isn't he? Martin Smith, thank you so much for the good question there. Let's see if we can grab some more. And y'all, thank you so much for asking the questions. One of the reasons we do this, we could just put up a video of it rolling out, or time lapses are cool or whatever, but we love to sit and hang out with you and answer these questions. So if you have a question for us, tag us in chat at NASASpaceflight. They go into a special queue. We don't always answer them right away. Like right now, there's some questions that are 15, 20 minutes old, but if you get a question here, we will try to get it answered for you. The rocket is approaching the launch pad. It's getting really close there. Let's see here. Here's one. Chris, I don't know this one off the top of my head, so I may have to try and Google it. Do we know what speed the transporter is moving the rocket right now?
Oh.
What's the max speed? Yeah. I'm Googling.
No, I do not off the top of my head. It makes it 1,200 feet in about... Well, it started rolling out about half an hour ago, less than half an hour ago, and it's already more or less at the pad. So it goes quicker than like the crawler transporters take things out. I believe to and from pad B right now, but I don't know the actual speed of it.
Yeah. I know that ULA has tweeted it before, and I've seen it, but I don't want to say the wrong answer. I'm rapidly Googling, trying to find the tweet, where I'm almost positive Tori Bruno told us the answer to that at some point, but I can't find the tweet. I'm going to keep looking for that and see if I can find the answer there on the speed, because I'd like to know. And something, United Launch Alliance and Tori Bruno are really cool too. If we tweet at them, they may not answer in real time, but we would probably get an answer on Twitter. I'm almost positive that they've answered that before, though. Let's grab another question here. Oh, this is a good one. Akash says, doesn't the liquid oxygen boil off during the coast phase in the Centaur upper stage? So I think that comes down to, does the Centaur have anything to do after it puts it on the ejection trajectory, the transport trajectory?
Wait, what was it? What was the actual question, Daz? I did not follow your connection to what does the Centaur do afterward. I thought the question was about LOX boil off in Centaur.
Yeah, it's about LOX boil off.
Yes. So liquid oxygen burn off or boil off in the Centaur is a thing. They know based on the multi-layer insulation blankets that are on there and the insulation that's on the Centaur, they know what the boil off rate is, more or less. So that is all part of the trajectory calculations, part of the how much propellant do we need to leave in the Centaur at the end of the first burn that gets you into Earth parking orbit. How much LOX and liquid hydrogen, liquid oxygen will be in the Centaur at the end of the coast when the RL-10 reignites. So all of those boil-off rates are taken into account to ensure that there's enough propellant left in Centaur with enough propellant reserve and margin as well to do that trans-Mars injection burn after they initially get into a stable Earth parking orbit.
Right.
Which is the first part of the ascent, is to get into Earth orbit. Then you coast for a little bit, then you do the trans-Mars injection burn. So yes, the boil-off rates of the Centaur in terms of its propellant are all factored into that.
Gotcha.
But it does keep boiling off. It does lose stuff during its coast.
Right.
Yeah.
I read that completely differently. I thought they were asking about the coast phase while it was on the way to Mars. So after it's done the transfer burn, and then Centaur coast along and the rest of the fuel is burning out. I was sort of going along. Centaur doesn't do anything once it gets to Mars, right?
No, and actually the trans-Mars injection burn. So all of the rockets that we have seen do the trans-Mars injection burns, right? The H-2A, the Shenzheng 5, and in 2 days the Atlas 5, and the Centaur upper stage. They're not. This is kind of like. Okay. It's sort of like how SpaceX on the landing. I hate to bring everything back to SpaceX, but it's the analogy that works best in the spaceflight industry for this. So,
Sure.
when the Falcon 9s are coming back to land, either on the drone ships or here at LZ1 and LZ2 at Cape Canaveral, right? When the entry burn is done, they're not actually targeting the landing location, right? They don't target the landing location until the landing burn begins, so that if the landing burn fails, you don't destroy the landing pad, right? It's kind of the same when the rocket stages are doing the trans-Mars injection burn, only Mars is your landing pad.
Right.
The rocket's upper stages are trying to get you just close enough that you can then use thrusters on all the cruise stages or the probes themselves to push yourself over to actually intercept Mars. The whole point being that the probes will then be in the proper trajectory to either insert into orbit or, like Perseverance will do, slam into the Martian atmosphere and land, while those stages go right by Mars without stopping and just enter prolonged orbits of the sun.
Right.
And that's what they're trying to do. So the rockets are actually trying to get you on a trajectory that slightly misses Mars.
Yep.
And then all of the payloads get themselves back onto the proper track. They do like that final pulse burn to get onto the proper trajectory to intercept Mars. So
Gotcha.
yes, that is the long way of setting the stage for the answer, which is once the stages do their trans-Mars injection burn, they're done. They don't do anything else. They will just happily orbit the sun until the sun explodes in 5 billion years.
Until the sun explodes. Nice. That sort of takes us into another question. Somebody was asking, how close does the Centaur get to Mars? And we just answered that question. It doesn't impact Mars. The Centaur is going to be on a trajectory that sends it past Mars, but it doesn't crash into Mars. And then it's going to end up in a solar trajectory because the Centaur won't go into orbit around Mars or anything like that. It just sort of heads on by and drops off the payload.
Exactly. And a good way to think of it, because we call it the trans-Mars injection burn, but what the rocket stages, the two that we've already seen launch and Perseverance in 2 days, is they're actually going into what's known as a sun orbit, a heliocentric orbit,
right,
that is designed to intercept Mars. So it's technically an Earth escape heliocentric Mars intercept orbit is what you're trying to get these probes into. But yes, they're technically going into a sun orbit, a heliocentric orbit that just intercepts Mars in 7 months.
Yeah, that leads us right here to another question from Jeff. After the Centaur releases Perseverance, does it have to do a deorbit burn? Does it destructively re-enter? And the answer to that's no. Centaur is going to end up in a solar orbit, a heliocentric orbit. It's going to go past Mars and just keep on keeping on. You like my noise?
I do. That was perfect. Right past Mars.
There's no air in space, so even if you had it, anyways, whatever. Centaur will keep on keeping on as it drops. It's almost like dropping off the kids at school or whatever. They're going to go down to Mars and rove around and fly their drones and stuff, and Centaur's just going to be out in a solar orbit until the heat death of the universe or whatever. So let's grab another question here. And again, y'all, thank you so much. There's so many cool questions. We never get a chance to get to all of them. There's some gratuitous zoom on the Mars 2020. You can actually read Mars 2020 in Atlas there on the camera. Chris, that's a fantastic shot right there.
I figured you would appreciate that. I figure while they're stopped, it would be a good time to zoom in.
I think they're looking for the keys to the gate. Like somebody needs to open the gate, and they're like, "Who had the keys?" Bob, I thought you had the keys. There's actually a gate they have to open to let the rocket into the launch pad. It's moving again though. I got the answer to. I'm squinting down to 2020.
Very slowly. Yes, it is. Yes, it is. They started
rolling coasting again. So the maximum speed, according to United Launch Alliance, Brady actually looked up that tweet for us. It says the MOP will transport to the vertical integration facility, and it'll move at about 3 miles per hour is its max speed. So it looks like it's going a little bit slower than that right now, but 3 miles per hour is a pretty brisk walking pace, I think, right?
It is. It's basically a standard walk, like if you were just going to take a stroll around your neighborhood. And remember that, so we saw it doing that 3 miles an hour when it was on the long straight array, right? It goes a lot slower when it comes out of the VIF, the vertical integration facility, and it goes a lot slower as it's approaching its mounts on the pad.
Yeah, it's like you going slower as you pull out of your driveway and then parking at the office or grocery store or whatever. But once you get on the freeway in between, you're like,
yes.
All out, 3 miles an hour. Here we go.
Yeah, I don't know about other drivers, but I wouldn't go screaming into my garage in my car at 80 miles an hour.
Yeah, no. Oh, here's another super chat. Mark, thank you so much for the 10 Australian dollars. Appreciate the great work, NSF. Mark, thank you so much for the support. We appreciate it. I know this is a different thing. This is a really special thing. Like, there's so many tests. We see so many launches. I'm going to make the comment that we see rollouts less frequently than we see launches. Would you agree with that, Chris?
Oh, yes. Oh, yes.
Yeah. So this is a super special thing to be able to see the actual rollout of the rocket. Launches are super exciting, sound and fury, don't get me wrong, but this is just really cool to see all the work. Remember, when there's a launch, there are hundreds of hours of work that happen before it and hundreds of hours of work that happen after it. The launch is a point in time that takes a lot of work to get done. Thousands of hours probably is the right way to say that. But
well, and I mean, and years,
this one,
actually,
yeah.
because you go back, I mean, this mission was approved 8 years ago, right? And now it's coming to fruition, right? This is also, it's also 100% worth pointing out that before the rover actually got its name, this mission was from the beginning known as Mars 2020. It was always targeting this interplanetary launch window. And unlike the previous NASA mission, which had to delay one Mars cycle because something wasn't right on InSight and they needed to fix it to get that particular science instrument up and running for that mission, and it had to miss a window. Perseverance, damn, I did it again. Curiosity, no, Perseverance. They're cousin rovers, forgive me. But no, for Perseverance, I mean, that timeline that they laid out to build it and get it ready, and they nailed it. And here we are on the pad, exactly when we expected to be.
That would be, yeah, that's just fantastic that if for a second there it looked like the rocket was in a cage because it was right there in the frame of that lightning tower. And I'm like, oh, nobody puts a rocket in a cage. So anyways, let me grab some more questions here. Let's see.
Let's see if we can do rapid fire questions, because with it at the pad, they're going to tell us we've got to go at a certain point. And I don't know how much warning we're going to get. So let's see if we can do rapid fire questions as it approaches the pad.
Gotcha. So I can do a couple rapid fire questions really quickly here, then I'll kick one over to you, Chris. Here is one from Digi. They asked, why does ULA use different tips on the side boosters versus the traditional cone shape? Corey Bruno answered that one on Twitter a little while back, and that shape of those side SRBs, so the white boosters that are on the bottom sides of the rocket, those strap-on motors, that curve at the top is very specifically designed for the aerodynamic loading and aerodynamic features of the Atlas V rocket. Other rockets don't need that shape. You'll see different shapes on Vulcan when it rolls out to the pad, but that is very specific to the design of the Atlas V rocket with those boosters on the bottom and that sort of ramp shape. Good question.
And specifically too, those nose cones, those slanted angular nose cones, will be used on the next Atlas, which uses a different solid rocket booster set. The next mission will transition from the Aerojet Rocketdyne AJ60As, which you see on this rocket, to Northrop Grumman GEM 63s. And the GEM series of rockets have flown on the Delta lines before with the normal standard pointy tips to them, but they will use the same curved ones for the Atlas because it's specific to the Atlas.
Yep, absolutely. Here's another question from Elliot. What fuel does the booster use? So the main booster itself is going to be RP1, which is space-grade kerosene. Can I say it that way, Chris? Space-grade kerosene?
You sure can, Dust.
Cool. And a liquid oxidizer. So you have your fuel, you have your oxygen. RP1 is the fuel, oxidizer is the oxygen. And then the boosters on the side. Chris, do you know what the technical name of that is? I mean, they're solid boosters.
HTBP, hydroxyl terminated polybutylene.
Thank you.
Is what it should be.
hydroxy terminated polybutylene. There we go. Is the fuel for the side boosters, that solid fuel. So another good question. We're continuing to speed run.
And then hang on. And then the Centaur upper stage uses liquid oxygen and liquid hydrogen.
Ah, thank you. Yes. The Centaur upper stage uses that ultra efficient liquid hydrogen there. So let's see. Is the launch window just a second? What is our launch window for Thursday morning?
Great question. No, our launch, the total launch window is 2 hours long. It opens at 7:50 a.m. Eastern and closes at 9:50 a.m. Eastern on Thursday, the 30th, which is 11:50 to 13:50 UTC. Now, the way ULA does it and the way the Atlas V can perform it from a trajectory standpoint is we have 1 single second instantaneous attempt every 5 minutes of that window. So basically you have a single second attempt at 7:50, another one at 7:55, another one at 8, then 8:05, 8:10, etc., 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 onward to the end of your window at 9:50. And that's because Atlas V has something, the Centaur upper stage has something called RAN steering, right ascension of the ascending node steering, which means that you have more, the rocket can self-correct the dispersions in its own trajectory by launching outside of the nominal to the second. This is the most efficient, that places us on the exact trajectory we need to go to. The Centaur upper stage can actually compensate for that and get the rocket onto the proper track through that RAN steering. But because of that, you can't do that for every single second. You can't build launch windows and software trajectories for every single second of a 2-hour window. It's more efficient to build them single second every 5 minutes. It's the same thing we saw with Solar Orbiter back in February, although we didn't need it because they launched right at the top of the window. But this is what the Atlas V usually does for these interplanetary windows. You have single second discrete windows every 5 minutes throughout the duration of your overall window.
Gotcha.
Yes.
All right. I am going to grab again. Hey, M-Day, thank you very much. That was a very good question. Y'all, we're getting through as many of the questions as we can here. This is a good one. Sandy AP, what are the umbilicals connected to the Atlas V? So you can see going from the transporter, the big vertical thing that says ULA on it, right? There are little lines. There's like hoses going from that mobile tower over to Atlas V. Actually, we can zoom in. There you go. So do we know what those are for, Chris? You want to take that one?
Yes. So there are a whole series of umbilical lines for the Atlas. So some of them are physical connections to keep the vehicle vertical onto the pad, while it's on the pad. Some of them provide purge air. Some of them provide nitrogen purge, gaseous nitrogen purge. And some of them further up the tower are actually the propellant fueling lines for the Centaur upper stage, for the liquid oxygen and the liquid hydrogen that the Centaur uses. And then some of them too, you can't really see them here. There are some lines that actually go inside the payload fairing, which provide purge air and environmental control to keep the climate and the humidity levels and the temperature levels inside the payload fairing within the mission-specific guidelines.
Yep. All right. That actually brings us to another good question here. We've all seen The Martian, right? And we've seen Mark Watney keep himself warm with an RTG in his rover. And this rover is actually powered by an RTG, isn't it, Chris?
So I admit you were breaking up there, but I think the question was, is this rover powered by an MMRTG, a nuclear power source?
Yeah, that's correct. That's correct.
Yes,
yeah, you got it.
Yes, the answer is yes. Perseverance, like Curiosity, has a radiothermic generator on board, which produces heat and power from the decay of nuclear material.
Oh, we might have just lost Chris there. Chris, you still there?
I'm still here. Can you hear me again?
Yeah, we just lost you for a second. You sound good now.
Yeah, hang on. Someone tried to call me, and apparently my phone didn't. Decided that even though I put it on Do Not Disturb, that it was going to let the call come through. Anyway,
what part of Do Not Disturb do you not understand?
Say what, Das?
I said, what part of Do Not Disturb does the phone not understand?
I know, right? But anyway, the overall point that I was making, it's a very small amount of nuclear material that's in it. It's encased in a way that it's built to withstand most types of launch vehicle failures. And even if it were to crack or fail in the event of a launch failure, the overall risk to the public in a launch failure event like that is very, 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 very low. And it's why they'll really be monitoring winds on the day. of liftoff, and it's why we have a little bit more closures and a little bit more land space closures to the general public
Right.
than previous Atlas V missions would.
Gotcha. Here's Chris, and I'm just going to keep hitting you with questions as fast as they come in. Again, y'all, thank you for the super chats, channel memberships, stuff like that. I'm trying to get through as many of the questions as we can here. This one is from That Astronomy Guy asking, why doesn't Atlas have the same burn right before the Delta IV Heavy launches? So, Astronomy Guy, I think you may be speaking of the Delta IV Flame Festival, where we have a big hydrogen burn-off that happens right before the Delta IV launches. If you've ever seen a Delta IV launch, Delta IV is actually powered by liquid hydrogen and liquid oxygen, and they chill down the engines before launch by running liquid hydrogen through it. Of course, hydrogen, if you've ever seen blimps, the hydrogen actually rises up around the rocket, and then at the time of ignition, any hydrogen that's sort of accumulated around that Delta IV rocket gets burned off. It's nominal, it's expected, but it's all because of that pre-chill down that they do through the engines with the liquid hydrogen. They just run it through to chill down the engines, right? Atlas V here does not use liquid hydrogen on the main booster stage. Atlas V uses RP1, which is a different type of fuel, and they do not need to run. They don't just spew RP1 through the engines on the Atlas V before it takes off. And even if they did, it would puddle on the ground. It wouldn't go up into the atmosphere like hydrogen, normally a gas versus normally a liquid, right? So that's why we don't get the big ball of flames, the flame festival, I like to call it, that you see on the Delta IVs here for an Atlas V, a different type of fuel and a different engine startup procedure, I think is the right way to say that.
And Das, we've probably got time for like a question or two, but people are starting to matriculate back, so I think it's going to be called here pretty soon for us. So if we've got a couple more questions, happy to take them. I'll have to go, but I mean, obviously you're free to keep asking questions after I leave.
Yeah, absolutely. And Chris, zoom it out just a little bit so we get sort of the full picture of the rocket here at the pad.
Yes.
Yeah, like the tip and then down to the bottom of the SRBs. And yeah, that looks cool right there. All right. Grab another couple questions. Here we go. Why does Perseverance need the largest fairing? It seems like there's a lot of empty space above it in the fairings from the official photos.
Because 5-meter payload fairing has nothing to do with the height of the payload fairing. It's the width of the payload fairing.
Gotcha.
And Perseverance needs a 5-meter wide payload fairing. That does result in there being a lot of room up above it, but it's width, not length for this one.
Gotcha. And I believe, are there a couple different lengths of 5-meter fairings? Like, can you get the short, medium, and long? Or is that just the 4?
And, there are, and this one is not using the longest of the 5-meter payload fairings as well. It's also a function, in this case, of Perseverance needs a 5-meter payload fairing because of the number of solid rocket boosters. The aerodynamics change when you move from just 3 solid rocket motors, which you can have a 4-meter payload fairing for. But once you move to 4 or more, 5 being the max for the Atlas V, the aerodynamics of the vehicle change through the dense lower atmosphere as your thrust to weight ratio is a lot higher. And that mandates a 5-meter payload fairing for 4 solid rockets. So that's what gets us the 5-meter payload fairing for today.
Gotcha. Yeah, there you go, Sandy. That's a good question. Thank you for asking that one. Chris, one more, or are you packing up?
One more, and then I gotta go. Yep.
One more. All right, let's see. This is a good one. Jordy asked, is this just a NASA mission, or is it a collaboration with ESA, JAXA? Who all's involved with Mars 2020 here?
Yeah, so some of the international partners do have a hand in some of the technology and some of the science experiments and the overall suite of instruments that are on Curiosity. However, it is a NASA-led mission. That is the answer.
That's the answer. There you go. A nice short and sweet one for the last question there. So we've come up on what we understood was the end of your time out there, right, Chris? We thought 11:10, 11:15 was going to be about where we're going to go.
Which is about right, which I see we're at 11:15, so perfect. We're right on time, yay!
Yeah. Chris, thank you so much for making it out there today and going through all the security checks and toting all the camera gear around. It's really special to be able to see the Mars 2020 rover roll out to the pad down there at Cape Canaveral. And we wouldn't have this live shot if it wasn't for you toting all the gear around and answering questions and all that sort of stuff. So thank you so much, Chet.
Hey, it is my absolute pleasure to do so. I will actually be now. The cameras, the live stream equipment won't be back here tomorrow, but I'll be back here setting Julia Bergeron and Nathan Barker's cameras at the launch pad. So we will have remotes, hopefully some remotes to share with you and images from the pad after liftoff. And then, of course, I will be back here bright and early Thursday morning for our live stream of the launch of Perseverance to the Red Planet, the third of the 3 Mars missions departing in this current Mars transfer window after the Al-Amal probe from the United Arab Emirates and Tianwen-1 from China.
What time do we start Thursday?
And we'll have timings and everything specific to that a little later to share with you. But
Gotcha.
That's my schedule for the next couple of days, Das.
All right. Well, Chris, like I said, thank you so much for rolling out there with the camera and getting it all set up so that we could watch Mars 2020 roll over to Slick 41 there. We really appreciate you. Chat, up there at the top of the screen, you can see Chris Gebhardt. He's the assistant managing editor. It just went away. Put it back, please. The assistant managing editor for NASA Spaceflight. You can find him on Twitter at ChrisG_NSF if you want to keep up with the latest spaceflight, rocket, whatever news. Toss him a follow over there on Twitter. We'll put a link into chat as well. But Chris, okay. I think you're clear to pack up and get on out. Yeah. All right.
So I'll talk to you later, Das. Thank you, man.
Take it easy, Chris. Thank you so much. All right, folks. I think you should be able to hear me. Chris is clear to pack up. Chris, if you hear me there, your camera is clear and you're ready to go. Again, I can't say thank you enough for Chris going out there and bringing us that live feed. I used to do all this myself, right? So I would do streams and I would be the person who packed up the camera, and then I have to drive down to the Cape, or I'd have to go over to, to Vandenberg or wherever I'm going. And then when the stream was live, I had to host it. I had to run the server. I had to do everything all myself. And I can't tell you what a joy it is to be a member of a team now with NASA Spaceflight that actually has people sort of stationed all over. So I get to hang out here in the comfort of my studio and talk about the Atlas 5 rollout while we have a fantastic camera from Cape Canaveral. Later today, I'm going to have a fantastic camera from Boca Chica, Texas. Probably. We'll see. I don't need this. I'm not listening to Chris anymore, so I don't need this. Take that out of my ear. Anyways, but thank you all so much for joining us. Let me see if there's anything else that I've missed here. Looks good. I lost my hand. I know every now and then it's like again, thank you so much for joining us here. A very special thing, that Atlas 5 rollout. We don't get to see those very often. Like I said, it's very cool that we have the permission from United Launch Alliance to take the camera out there. They escort us in. They get everything all set. And they allowed us to be there for over an hour so that we could bring you that view this morning. But we will plan to be back a little bit later. Testing probably happening down from Boca Chica, Texas. If we get indication that there's going to be any Starship testing down there at Boca Chica, we will certainly be live back here on the same channel. So anyways, let's see if there's any other final questions or anything like that. There was one that I didn't grab earlier. How far into the future can they calculate the heliocentric orbit Centaur will have? Oh, Carl, I can't answer that one myself. How far will they calculate it? I imagine they have to track it and recalculate it after there's gravitational perturbations from masses in the solar. I don't know the answer to that one. It's probably one of the reasons I didn't click on it earlier, because I didn't know the answer. But I appreciate you there, Carl. Thanks for asking the question. And there was one, Ron Smith. Can the crew access arm access the fairing quick access panel on the pad? Do you mean, could they crack open the fairing and work on Mars 2020 or the rover while it's rolled out to the pad? I don't believe that they would put anybody inside of that fairing while it was on the pad. They don't have all the structures around it. Even if they could sort of move the crew access arm out, I'm not sure that it's going to really line up with the access port. If they had to get inside the fairing, I would imagine that 99% of the time they're going to have to roll that back into the VIF, and then they have the platforms. There's actually these cool fold-down platforms that fold down, sort of cupping the sides of the rocket, and then people can get right up against it if they need to work on it. I don't believe that we would see anybody trying to enter the payload fairing while the rocket's on the pad. Good question, though. Good question on that one. Thank you for asking that. Yeah, you love it when streamers go out of frame. My studio's only so big, okay? studio is only so big. I could actually get up and walk to the back wall, but oh, I even got dressed for the occasion today. I've got my Get Your Snacks to Duna shirt on, my Kerbal Space Program Mars related shirt. I don't actually have a Mars 2020 shirt, so I had to toss on the Get Your Snacks to Duna shirt today. Seeing if there's anything else. I think we're good to go. I mean, in the meantime, if you want to keep up with what's going on, you can follow all of us on Twitter. At NASASpaceflight is the main Twitter account for NASASpaceflight, right? You can follow me. I'm right here. This is me, K Space Academy. Chris G is Chris G_NSF. You saw him over there as well. You can toss a couple links into chat really quickly or something. We actually need some commands. That's what we should do. Oh, you've got your Roadside Rocket shirt on. Nice. I don't have a NASA Spaceflight shirt on right now. I have one within reach. No, I don't. I don't have a NASA Spaceflight shirt on, but the NASA Spaceflight shop has some other cool shirts and stuff like that, t-shirts. Thanks for streaming. We are happy that we're able to bring this sort of stuff to you. We really do enjoy it. And again, thank you all so much for the super chats and channel memberships and people that show up to the stream and people that retweet things and all the different things that happen. We would not be able to do this. Like Chris said, we're fielding multiple broadcast kits, one down at the Cape, one down at Boca Chica. There's actually 2 broadcast kits at Boca Chica because if there's a hop and something fails, we need to replace our gear without having to ship anything. So we have multiple broadcast kits. I've got broadcast kits here. They look like this. So when I say broadcast kit, this is actually what a broadcast kit looks like. It's a live-use solo mobile encoder. You give it an HDMI signal. You give it an HDMI signal right there, and it uses 4 4G modems to send the signals up. It's sort of like, not news grade, but it's news grade heritage, I guess, encoders that we use. But we've got multiples of those stationed all around. So whatever's happening with spaceflight, we can bring you a live stream with our own live footage. We don't just consume somebody else's live footage. So anyways, I think that's going to be the end of our stream here today. I appreciate everybody hanging out with us. Thank you so much for joining us for that Atlas V rollout. Join us again for this mission Thursday morning. We will be live streaming from Cape Canaveral the launch of Mars 2020. That's scheduled for early in the morning. And there's those Twitter links. NASA Spaceflight, thank you. There's the Twitter links over there in chat. Yeah, chat's on this side on YouTube, isn't it? Yeah, cool. All right, point in the chat right there. It's like right. That's where you're supposed to click. In Yorkshire. That was probably down here. Thank y'all so much for all the support. Thank you for letting us do this and share these cool things with you. You know I could sit here and talk forever. I'm going to go ahead and shut it down for now. Stay tuned. Follow the channel. You know where to click. Turn on the bell. If we go live from Boca Chica for some testing later today, you want to get notified. You don't want to miss whatever's happening with potentially a static fire of Starship SN5. Subscribe and ring the bell, turn the notifications on, and you'll get a little notification on your phone or wherever. I mean, you have to configure it to let you know that we're going back live again to show you some other cool space news. But for now, John Galloway here with NASA Spaceflight, signing off from the NASA Spaceflight studio, which is a spare bedroom at my house. And we will see you next time. Later, nerds.
Chamber pressure looks good.
Following up. Roger, roll, planet. Water towers fly! Flight downside of speed off. Off.
Yikes. You bet. Okay. We don't need any more of these.